Okay, so now we are in Chapter 1. Chapter 1 is a specific task about creating MC lag. So in Chapter 1 we have two parts, Part 1 and Part 2. In Chapter 1, Part 1, we have to create MC lag between two MX nodes and another MC lag between two Q of X nodes. The MC lag between the two MX nodes, here we have MX1, MX2 have an MC lag towards Q of X1 and another MC lag towards MX2. Then we have in the MX back-to-back links we have a normal lag. This normal lag will be used to establish the ICCP and it will be used for the ICL link. Between Q of X1, Q of X2 we have a back-to-back link that will be used for the same purpose of creating ICL and establishing ICCP. And we have an MC lag towards the Q virtual MX6, which will be emulating a server side. So we have an MC lag here between the Q of X1, Q of X2 towards data center servers. We have 3 VLANs passing through this MC lag between the server side and Q of X. Before configuring this task, we will just remember the MC lag hierarchy. So in the MC lag, to establish an MC lag between two nodes, so we need to have these two nodes within the same service ID. So MC lag actually have a multiple configuration hierarchy. The first hierarchy, while you are enabling MC lag, each node in the MC lag pair, actually MC lag, you can configure even MC lag between more than two nodes. So regardless of the number of nodes that you will be configuring MC lag, they need all of these nodes that will be running MC lag together or running ICCP together. They should have the same service ID. In this example, let's say you are using service ID number 1. Then we have BE1, BE2 to start creating MC lag interfaces. These MC lag interfaces should share the redundancy group. Actually, we could have one or more redundancy group, but we have only one service ID in each node participating in ICCP. So in this redundancy group 1 is the redundancy group that's being shared between BE1 and BE2. Okay, under this redundancy group 1, we can have one or more MC lag interface. So each MC lag interface is assigned a number. So this MC lag interface is assigned a number 1, which is shared towards CE1, is connected to BE1 and BE2, which is actually connected to MCAE interface 1 here and MCAE interface 1 here. We have another CE interface, which is CE2, is connected via a lag towards BE1, BE2, but this actually lag interface have a different MCAE ID, which is connected here to AID number 2, and here is the MCAE ID is number 2. Within the MC interface, the MCAE interface, each node is assigned a chassis ID. So here, this node is assigned a chassis ID number 0, and this node is assigned chassis ID number 1. The same for MCAE ID 2. Here, if you can see, BE1 is assigned chassis 0, BE2 is assigned chassis 1. Then, under the interface as well, each interface is assigned in the LACP. The LACP, both chassis, both nodes should have the same LACP system ID and admin key. So here these values, actually there is no point, let me use, here is this, actually this value, system ID and admin key here in BE1 and system ID and admin key in EE2 should exactly use the same value, as well as for MCAE ID2. Going back to our here, okay, so we'll take them one after one. So we have to, in the first requirement, which is about MC lag between Q of X1, Q of X2, we need to configure VLAN 100 between Q of X1 and Q of X2 in the XE00, which is the back-to-back interface between the two of X's. Just let me highlight while I'm talking here. Okay, so this interface is the back-to-back interface between Q of X1, Q of X2. Then requirement Number 2, we have to configure an IRB interface for VLAN 100 in virtual queue of x1 and virtual queue of x2 using this IP schema 192.168.100/30. Then we need to enable MC lag between queue of x1 queue of x2. We need to enable ICCP session between queue of x1 queue of x2 over the IRB interface that we just created. The ICCP session should be authenticated via MD5 hash algorithm using the session authentication key JNCIE. The MCAE interface should be towards the server's downside, towards the server should be in active mode. MC lag support active and active standby. The requirement here is to use the active. The other MCAE configuration parameter should be done by yourself. So the other parameter like the chassis ID, like the system, the LACP system ID, admin key, all of this should be to be done by ourselves. We need to use the out-of-band interface for additional checks to avoid split horizon. Then during split horizon, Q of x2 should become the MC lag active. So in case, let's say that there is the back-to-back connectivity between Q of x1, Q of x2 goes down, this is called the split horizon case, where the ICCP session goes down. In this case, the requirement here is that Q of x2 should become the MC lag. Should become the MC lag inactive. Sorry, I spell it active. So Q of x1 will be the active, while Q of x2 will be inactive. The MCAE, the multi-chassis AE interface, should pass VLANs 10 and 11 and 12. So let's go and start. Okay, so now we're gonna start. Here is our lab topology. We have MX1, we have actually using secure CRT with 4 sessions, one for MX1, MX2, Q of x1, Q of x2, and the last one for virtual MX6, which will not be actually doing any changes because it's already preloaded with the configuration for the server side. Let's just start from Q of x1. So here we can do all configuration on Q of x1, then just copy and paste Q of x2. So first of all, we need to configure the service ID. Then we need to remember we need to configure to enable the aggregate Ethernet. So here in our example, we need this virtual Q of x1 will have three interfaces, 3 aggregate Ethernet interfaces, 1 down and 2 up. So we need at least 3. Okay. Then we need to enable the ICCP. First, before enabling ICCP, we need to configure the back-to-back interface, which is XE001. So we'll enable this back-to-back to be a trunk interface, and VLAN members 100. Then we have to configure VLAN 100. Then we have to configure an IRB interface. Also, before going this, we have to enable IRB 100 to be the SVI or the routing interface for VLAN 100. Okay. Then we need to configure the IP addresses. So here we're going to use 192.168.100.1. Okay. It is always recommended to use a kind of a static MAC. This is my actually own way of recommendation as a best practice to use static MAC addresses configured under the IRB interfaces. It will make the troubleshooting easier and to understand while looking to the switching table or to the MAC tables, the MAC addresses of the IRB interfaces. So I do recommend to use static MAC configuration. Okay, so under the IRB interfaces, we can assign the MAC per unit. Then we can establish the ICCP protocol. Under the ICCP protocol, we have to specify our local address. Then we have to specify the peer address. Then here we have to specify the keep alive intervals called the liveness detection. I use minimum interval of 300 milliseconds. Actually, by millisecond, I use 300 milliseconds, which is equal to 3 seconds. And actually, he is saying here we need to use a backup way to detect split horizon. As a backup way to detect split horizon, we have another keep alive running over the out of band management. So we have between Q of X1, Q of X2, we have this back-to-back interface. In addition, we have each Q of X connected to the out of band management. So we enable another keep alive, ICCP keep alive in the out of band management network. So here I know the IP address of Q of X2. Backup peer 92.0.0.62. Then we need to enable the authentication. Set authentication key JNCIE. Then we have to list the redundancy group between Q of X1, Q of X2. Actually, we don't need more than one redundancy group, so I'll use only redundancy group 1. And now we are done with the ICCP. It's very, very important because we're gonna use this XE001 as ICL inter-chassis link. We need to specify this as the multi-MC-lag multi-chassis link. So this we have to do it using set multi-chassis protection. For multi-chassis protection towards this pair, we'll use interface XE000. So this is actually a very, very important command. While you are doing a multi-chassis, you have to specify which link will be used as ICL. Now let's go and configure the interface towards downside the MC-lag interface itself. So we are using here XE001 and the other side XE001. So here edit interface XE001. Just need to delete unit 0 and use Ethernet options 802.13 EE. This interface will be member interface of AE1. Then top edit interface AE1. Then we need to configure AE1 under aggregate Ethernet interface. We have to do very, very important things is to use LACP active, then system ID. Let's select any system ID. System ID is a MAC address like, and then admin key. Let's use 1. Then we have MCAE, the multi-chassis aggregate Ethernet interface. We'll use MCAED. Let's use edit MCAE. Edit MC. Okay. Then we'll set the MCAE interface to be number 1. This is number 1. This number should be common between the two pairs of MC lag. So in Q of X1, Q of X2, this number should be shared for the same aggregate Ethernet interface. Then chassis ID here I'll use 0, other side should be 1. Then here mode active, other side also will be mode active. Status control, one of the nodes should be active and the other one should be backup. So I'm using here status control active. Then the redundancy group, this aggregate Ethernet interface is part of redundancy group 1. Actually, we have only one redundancy group. Then we have a very important case, which is in case of split horizon, this node Q of X1 should remain the active. So we say here in case of ICCP goes down, prefer status control active. This means in case of the ICCP goes down, this node will not change its MC lag or its LACP system ID. It will keep the LACP system ID as is, as we just configured it now. While Q of X2, because it will not have this command, it will change its own LACP system ID to the chassis local system ID. So from the CE side, it will detect that one of the links have a change of system ID, LACB system ID. So it will kick out from the client side or from the CE side, it will kick out the link towards Q of X2 and it will keep only the link towards Q of X1. Okay, so now we are done with the MC configuration. Let's configure the trunk itself, the trunk interface itself, the aggregate Ethernet as a trunk interface. So we're gonna configure unit 0, family Ethernet switching, interface mode to be trunk, and the VLANs to be 10, 11, and 12. Okay, so here is the VLANs that we need to configure between the aggregate Ethernet interface towards the client downside. So let's enable these VLANs. So we need now to enable 3 VLANs. Now we have 3 VLANs, 10, 11, 12, which is enabled in the trunk interface. Okay, let's review the requirement again. We configured VLAN 100 in the back-to-back interface. One very important thing as well, we need to enable in the ICL, in the protection link also, we need to enable the VLANs towards the client side, because the ICL protection link here actually is doing 2 things. It has the ICCP session running, and it acts as a protection for the MC lag. In case of one of the links of the MC lag goes down, actually the traffic goes over this, the traffic for this VLANs are going over this MC, the ICL link. So we need to enable all VLANs here. That is configured under the MC lag interfaces. This is under the protection link. Okay, let's go again here. We configured VLAN 100. We established XE00 as a tagging interface. We configured the IRB interface for VLAN 100, where Q of X1 is assigned this IP. We will configure Q of X2 later. Then we enable the MC lag between Q of X1 and Q of X2. We enabled the MC lag already. Okay, then we established ICCP session. We configured the ICCP session using the VLAN 100 IP addresses. We enable the ICCP authentication, MD5 authentication. Actually, MD5 is a hashing. Then we configured MC in an active mode. Other MC lag parameter we configured ourselves. We used out-of-band interface for split horizon, and during split horizon Q of X2 will be inactive. Then the MC should pass VLAN 10, 11, 12. We are done in this side. So what we need to do now is to configure Q of X2. So what we're gonna do, we'll do show compare. And we'll take all of this configuration that we have done in Q of X1 and copy in a text file. Okay, and start editing this configuration to be in Q of X2. So here just going fast, and under chassis aggregate Ethernet we'll keep it the same. For interface XE000, which is the back-to-back interface, it will be kind of a copy paste here, because it is also called XE00 on the other side. XE001, it will be the same. Then under the aggregate Ethernet interface, under AE1, both of them will be sharing the same LACB parameter like system ID, key ID, and both of them will be sharing some of the parameter under the MCAE, MC aggregate Ethernet. So both of them will be using the same aggregate Ethernet ID, both of them in the same redundancy group, but Q of X2 will be chassis ID number 1, as we say. One of them is chassis ID 0, one will be chassis ID number 1. Both of them will be in active mode. Status control, Q of X1 is active, Q of X2 will be standby. Q of X2 will not actually have this configuration only because in case of split horizon we need Q of X1 to be to keep the system ID of LCP the same. So in Q of X2 we remove this one. Then under the interface itself we need to enable trunk for VLAN 10, 11, 12, Then under the IRP interface here, we just need to change the IP address 100.1 to 100.2 and change the MAC address because IRP MAC address is unique here. This is a unique MAC address. Then under chassis, under the multi-chassis protection, the ICL interface, we just need to reverse the IP addresses. So this IP from Q of X2 towards Q of X1. Then under the ICCP, we need to configure the local IP to be 1, while the peer IP to be local IP address to be 102, and the peer IP is to be 101. Same redundancy group. Backup liveness protection, we need to specify the out-of-band management of Q of X1. Then the same parameters for ICCP keep alive, same authentication, same service ID, and same VLANs. Let's copy and paste this configuration in Q of X2. I'm using load batch terminal. Let's connect here and commit here and see. First of all, just to give it a few seconds, run show and just use run show ICCP here. Okay, so actually this is in progress. Let's first of all run show interface IRP, the IRP interface 100, then let's ping other side. Let's make sure some the IRP interface is created back to back and show ARP no resolve. Let's make sure we have the right ARP towards, here is the ARP, here is the MAC address that we used and the Q of X1. Okay, then now let's see if ICCP session get created. So still in progress. Now let's make sure that the interface AE1, okay, so interface AE1 is still down, which is normal because ICCP is not created yet. Okay, here ICCP session get established. Actually, what we need to see here, the ICCP session get, when it says get established, it means it is get established over the main interface. Also, we need to see the liveness detection is up, which means as well we have the backup pass or the out-of-band management pass is being used for the detection of ICCP peer. Let's wait for this. Yes, okay. So now here we have established and up. Okay, and redundancy group 1 is up. So now let's do run show interface MC aggregate Ethernet. So when we use this command run show interface multi-chassis aggregate Ethernet, actually we can see all aggregate Ethernet interfaces that's being configured. In this case we have only one, which is AE1. In AE1 we can see the local status is active, peer local state is up, peer status is active, peer state is up, and the logical interface AE1 0 is up. It is configured being in bridge mode, and here is my ICCP peer from Q of X2 towards Q of X1. Let's see the same. Actually, if we do extensive, we will show some extensive even information. Here is the extensive information. Here is the redundancy group is 1 under this interface, and the MCEE-ID, which is the AE1, MCEE number is 1. The mode of this MC link is active, but here is the own status control standby because now we are in Q of X2. Chassis ID is 1, other side chassis ID will be 0. The LACP system ID is 0000, and this number, which is actually configured in both sides, this should be common in both sides. Local system ID, peer system ID. If you remember, when we say during ICCP split brain, the Q of X2 actually will revert. Instead of using this LACP system ID, it will use its own system ID. This is the number that will be used in case system ID will be going down. Let's see the same on this side. Let's show interface MCAE extensive. Here everything is the same, but chassis ID equal to 0 and status control is active. Now let's see the interface, LACP interface towards the client. Interfaces run show LACP. Okay, here we have only one LACP interface, which is XE. One of the members of this AE interface is XE00001. So it is very important how to know if this interface is correctly running towards the client or towards the other side, towards the server side, is to use here collecting and distributing. Okay, collecting and distributing, which means that this interface can be used to send and receive the traffic. Let's see from Q of X2. Okay, if we need more extensive information, here's the more extensive information. It's the same interface, the XE001, which is member of AE, AE1. Actually, the local system ID is this number, and the remote system ID, which is the server side, the LACP system ID side, is this number. Okay, and also it is very important to look about the activity. Is it collecting and distributing, which means that this interface is correctly, is actually successfully running LACP. Now let's go from the server side. Here is the server side. Show interfaces, show LACP interfaces. From the server side, they have AE0, known as AE4. From the server side, we have AE4. AE4, actually from the server side, from Q of X6, we don't change any configuration. It is already coming with the configuration ready. From AE4, they have two interfaces, two member interfaces, XE000 and XE001. If you go to the diagram here, from the server Q of X000 and Q of X001, both of them are successfully running, are in collecting, distributing state. Okay, if we do some extensive information, you can see here in AE4, XE000, the partner, have this ID, which is the system ID that we configured manually, and XE001, the partner, also have the same interface. That is actually here, this device, or the server side Q of X6, is assuming that these two links are connected to the same system, because the system ID is common between this interface and this interface. When split horizon happen, what will happen? The Q of X2 will change its system ID, so this interface will have a different system ID, and in this case, Q of X6, or the CE side, will know that this interface and this interface are no more belongs to the same system, and it will kick out this one, because this one will retain its system ID. Okay. So by this, we are done with this task. So we are done with this. Okay, so back to the second subtask of part number 1, which is we are going to configure lag interfaces in Q of X1, Q of X2. Here, actually, it is simpler than subtask number 1, where we need to configure an aggregate Ethernet interfaces in Q of X1 and Q of X2 individually towards MX1 and towards MX2. So here, we need to configure this interface as aggregate Ethernet and this interface as aggregate Ethernet. If you remember, we used here aggregate Ethernet 1, so I'll use here, this is AE0, and I'll use this as a AE0. This AE0 is connected to MX1, MX2, and this AE0 is connected to MX1, MX2. Both of them are using XE002 interface and XE003. Okay. Okay. So by using XE002, XE003 from the Q of X side, the uplink AE interface on Q of X1, Q of X2 should pass VLANs 10, 11, and 12. So while configuring this AE interface, it should be done in a trunk mode, and this trunk should pass 10, 11, and 12. Make sure that communication inside server VLANs to relate the loss of uplink. So he's saying here, in case one of the uplink goes down, once the uplink between Q of X1 or Q of X2 towards the MX goes down, the server to servers communication should remain up, which means if we have this goes down, or this uplink goes down, So when I need to communicate from server VLAN 11 to server VLAN 12, actually they can use this uplink. Okay, so if this one of this uplink down, this one or this one or this one, the server to server communication, because actually there will be a requirement of a routing here from VLAN 10 to VLAN 11, there will be a kind of a routing here. This will lead us to a very important question. If I need to have VLAN, if I enable here VLAN 10, because I need to enable VLAN 10 and 11 between MX and Q of X, then I need to enable as well VLAN 10 and 11 and 12 here, because here I'll configure the routing. So VLAN 10, 11 will be there, and VLAN, if you remember, we configured VLAN 10 and 11 and 12 here as well. This will lead to a layer 2 loop, because VLAN 10, 11 is enabled here and enabled here. And in this case, as we'll be using the MX1, MX2 for inter VLAN routing, and also will be used as a backup for the case of link failure here, we need to disable, or we need to remove VLAN 10 and 11 from this ICL link, and we will use the back-to-back interface between MX1 and MX2 as an ICL link in this case. So in case host in VLAN 10 need to communicate with host VLAN 11, it will go to the IRB anyway. This is the IRB, okay, and then there will be a routing happening here. So when the routing happen here, the traffic will go back from this MX, go back to Q of X, same Q of X or different Q of X, we don't care, okay, and when it come back here, it will not pass this link. It will go only, it will have only this way to for the traffic to flow. So we need to remove Q of X, you need to move the VLANs 10, 11, 12 from this ICL link, in case we have such a setup where you have a layer 2 link here and layer 2 link here. You have to understand we need to remove the VLANs from one of the sides, because ICL, there is no way to block ICL links. Even if you try to run a spanning tree in ICL links, there is no way to run a spanning tree. So here we need to avoid have a spanning tree in a manual way. Okay, let's go to this again and read the requirements. So make sure that communication inside server VLAN to relate the loss of link failure. This requirement is tricky. Actually, this is my own note here, because while studying for this task in the JNCIE book, this requirement is tricky. It means that inter-VLAN communication should exist in case Q of X to MX goes down. This means VLAN 10, 11, 12. Either it will be it should be only enabled in Q of X1, Q of X2, because first time I did this actually requirement, I enabled VLAN 10, 11, 12 up and down, and this leads to a loop. So it should be removed from one of the ICLs. Okay, now let's move to the task itself. Okay. So from Q of X1 we need to configure the interface. So set interface 00, actually 00, 002 and 003. So I'll use AE0. I'm just deleting unit 0 and set the Ethernet. Aggregate Ethernet interface. I'll make this two interfaces members of AE0. Then I'll configure AE0 itself. Enable Iccp. Okay, so I now enabled AE0, which is aggregate Ethernet interface. That's normal AE interface. That's not an MC interface. From the Q of X side towards MX, it is a normal aggregate Ethernet interface. Okay. So now let's remove the back-to-back VLANs. Okay, so I'll keep only VLAN 100, which is used for ICCP. Now let's do show compare to understand what we did here. What we did here, we removed the VLAN 10, 11, 12 from the back-to-back interface between Q of X's. We kept only VLAN 11, and we understand why. Then we assigned XE002 and XE003 as a member of AE0. Then under AE0 we enabled LACP in active mode, and we bypass the 3 VLANs. Now let's take this configuration. Okay, it should be done as is without any changes. Let's commit here. And commit this side and show LACP interfaces. Now we have 2 LACP interfaces, AE1, which is the aggregate Ethernet interface towards the servers, and then AE0, which is towards the MX. If you see here, the status is detached, which means that interface does not have any active members. Both members are inactive, are in detached mode. Okay, so the requirement now to go in this part. Okay, the MC lag between Q of X1, Q of X2. Now create a AE bundle interface between MX1 and the MX2 over XE000 and XE001. This is the back-to-back bundle. If we go here, this is the back-to-back bundle that we need to configure between the 2 MXs. Configure VLAN 101 between Q of X1, Q of X, virtual MX1, virtual MX2 that bypass VLAN 101 as a tagged. Then create an IRP interface for VLAN 101 using this IP addresses respectively. Then we need to enable MC lag between MX1, MX2. We need to use enable IRB interface, the ICCP session over this IRB interface we just created up with MD5 hashing and session authentication JNCIE, the key. Then we need to use the out-of-band interface for additional check to avoid split brain, which is as we did in the last time. During split brain, virtual MX2 should be inactive, which is virtual MX1 should be active, so it should prefer the status control of active. Then we need to create 2 MC aggregate Ethernet interfaces, so we need to create 2 bundles now down, one towards Q of X1 and one towards Q of X2. The MCAA interfaces to be, both of them to be active mode, and all other MC lag parameters, MC aggregate Ethernet parameters to be done ourselves. Then we need to configure the MC aggregate Ethernet interface to pass the 3 VLANs 10, 11, and 12. Then we have these links down towards from MX towards Q of X to be trunk interfaces, and then we need to configure gateways for these 3 VLANs in both IRP interface, in both MX interfaces, using subnet 10.0.x, where x is the VLAN ID, which is 10, 11, 12, 254. The gateway should be 254. Q of X1, Q of X2 are gateways for these VLANs. We need to configure IRB. Okay, we need to configure IRB for VLAN 10, 11, 12. Okay, we need to configure IRB interfaces for VLAN 10, 11, and for VLAN 10 and 11. We'll configure IRB interfaces, and here is the IP range where MX1 will be 10.0, let's say 10.252, and MX2 10.0.10.253. Okay, and then we have to enable VRRB between MX1 and MX2 only for VLANs 10 and 11, for IRB 10 and 11. Whereas the VRRB VIB will be 10.0.VLAN ID 254. Virtual MX1 is the VRRB master for VLAN 10, while virtual MX2 is the VRRB master for VLAN 11. VRRB VIP interface should be responding to ping. VRRB authentication should be using MD5 with JNCIE key. Virtual MX2, virtual MX and 1 and 2 need to use any cast IRB for VLAN 12. So for VLAN 10 and 11 we are using VRRP. VLAN 12 we are going to use Anycast IRB. So now let's start the task by just enabling back-to-back leg interface. Okay, so now let's go to MX1, and now we need to enable back-to-back interfaces. We need to have these back-to-back interfaces have two members, XE000 and 001. We need also not to forget to enable the aggregate Ethernet in the global chassis level. Okay, so we need three aggregate Ethernet interfaces. If we make it more, that's fine. And don't forget that when we configure aggregate Ethernet, the count aggregate Ethernet starts from 0. So if we have 3 device count of 3 aggregate Ethernet, we have AE0, AE1, and AE2. Okay. Now we need to configure the AE0 interface, which is a back-to-back interface. To have it in active LACP, then we need to set unit 0. Here we are in the MX. We don't have family Ethernet bridging. We have family. We don't have a family Ethernet switching like in Q of X. We are using family bridge. Interface mode trunk, and here we have VLAN ID list. Okay, we don't have VLAN members. We have VLAN ID list. We need to enable VLAN 101, VLAN 10 to VLAN 12. Okay, so we have this is the back-to-back interface between the MX1 MX2. It will be used for two purposes. It will be used to carry the ICCP session, and also it will be used for inter-VLAN to carry all VLANs for the server side 10, 11, 12, which will be actually kind of an ICL for the server VLANs. Okay, let's configure. As we need to enable ICCP now, we have to enable the service ID. This is a mandatory while enabling ICCP. Protocols ICCP. Okay, before this, we need as well to configure bridge domains. We need to configure bridge domains, which is a VLANs, like a VLAN in Q of X. So VLAN 101. Okay, VLAN PD 101, routing interface IRP 101. Sunset VLAN, then VLAN ID 10, routing interface IRP 10, then VLAN 11, VLAN ID 11, routing interface IRP.11, set VLAN 12, VLAN ID IRP 12. So we have 4 IRP interfaces. Okay, edit interfaces IRP, set unit 110, edit unit 110, set family address. Okay, we need to configure this IP address. As I did before in Q of X, I prefer to use unique MAC addresses here. Okay, this is the MAC address of IRP 101 that will be used for ICCP. Then we need to configure for VLAN 10 set family INET address. This is the IRP interfaces to serve the servers, to serve the server VLANs. VLAN 10, where is IP address for VLAN 10? Okay, so configure IRP interfaces. I need to configure from 10.0. Okay, 10.0.10.251. Sorry, 252. The IRP interfaces for VLAN 10 and 11 is 252. 252/24, and as well that I need to configure VRRB. So let's make this VRRB group 10. Okay, in VRRB group 10, I'll use the virtual address. Should be 254, and accept data. Priority 110. This is the priority of 110. If I need to preamp it, which is in case if the primary goes down then back up, it will be resume its master membership. Then we need to enable as well authentication. Okay. So that is the VRRB configuration. It is the VRRB, as well as I need to set a unique MAC address for each IRB unit. Okay, I'll do the same exactly for unit 11, but actually it should be reversed. So in unit 11 it will be this way, 254, then but priority will remain 100, because Q of x2 will be 110. Okay, so here is the IP address 10.0.11.252 VRRB. Sorry, I need to change VRRB group. Just 1 second, let me make it 11. Okay, VRRB group 11. Oof, one more error. Need to set this to virtual address in subnet 11. Okay. Then the unique MAC address, I can use same unique MAC address for all units. Actually, by default, all IRB units having the same MAC address. So I can use different MAC address per unit, but actually there is no logic here. I can use the same MAC address for all units except the units that need any cast gateway, like unit 12. Then, if you remember from the requirement here in VLAN 12, we're going to use anycast IRB. Okay, so here for unit 12, set family address, I'll use anycast IRB interface, which means I'll use the gateway address, which is 254, in both MXs. So the family INET address will be the same in both MXs. Not like 10 and 11. 10 and 11 we have unique address, we have unique IP address, which is 252, 253 in the other side, but the common is the VRRB address. Okay, here actually we will not use VRRB at all, so we will use the IP address under the IP interface to be a common IP address. It's called anycast IP address. Okay, and here the MAC also should be common. So here is the trick of anycast. So for anycast interfaces, the interfaces that's anycast, which is shared between multiple devices, all of them should be used the same IP address, and all of them should use the same MAC. Okay. Let's do a commit check to make sure there is no errors, any syntax errors. Now let's jump to protocols ICCP, which is ICCP back-to-back between the two interfaces, the two MXs. Here is my local address, then edit the peer, set authentication, JNCIE, set liveness, minimum interval, 300 milliseconds with multiplier 3, backup peer address, 192. This I'm going to use the out of band management IP address of Q of X2. Redundancy group. Let's see if we okay. So the most important is to use authentication, backup, liveness detection is mandatory, and redundancy group list we have only one. Okay, then the most important configuration knob is to use the multi-chassis to define the multi-chassis multiple protection link towards my peer. I need to specify the peer address, what is the interface, which is AE0 that I'll use for as a multi-chassis protection link. Okay. Okay, show interface AE0, we are done with AE0. Now let's configure the interfaces down towards the Q of X's. So interface XE002, let's go back to the diagram. From our side, 002, this one is part of AE1, and 003 will be part of AE2, because this interface XE002 with XE003 in the other side are in the MC AE1, and these two interfaces are part of a different MCE. So for XE002, delete unit 0 and set data Ethernet options AE1, and top edit interface XE003, delete unit 0, and I'll put it as a part of AE2. So we have two aggregate Ethernet interfaces here. LACP active and active system ID. So we need to have a common system ID. Let's see, I'll name this 10, and then admin key 1, other one I'll use 20 as a system ID. MCE. Here is I'll use aggregate Ethernet interface, I'll use 1, chassis ID 0, mode active, status control active, and I'll use events ICCP down, prefer status control active. Let's see. Okay, so we have chassis ID, mode active, status control active, and most important, the MCE ID is 1. So this value is common, this is common, this will be different. So between the two chassis, and this one will be different between two chassis, and this one will not be configured in the other chassis. Then I need to enable this interface as a trunk. Interface mode trunk VLAN ID list 10, 12. Okay, then I need to configure AE2. In AE2, just I'll use different system, LACP system ID, and MCE2, everything the same, everything else will be remain the same. Edit interface AE2. Okay, now I believe we are done from MX1. Let's take all of this configuration, copy configuration from MX1, go to MX2. Okay, for MX2 there will be kind of a change here. Okay, the number of aggregate Ethernet is 3 as well, 000 and 001. It is the back-to-back interface, which is a common interface between the two MXs, so it will remain the same. XE002, let's see here, XE002, which is going to Q of X2. So there will be a change here, where Q of XE002, it will be part of AE2, while XE003, which is going to be a part of MCAE1. So here this will be 1, here there's a minor change here. The back-to-back interface between MX1 and MX2 it will be trunk interface carry 101, and from 10 to 12 the same. Here AE1, there is no change between AE1 and AE2 from the system ID. System ID will be 10, and for AE2 system ID will remain as is on both sides. But here there will be a change in two main parameters. For AE1, the chassis ID will be 1 and status control will be standby, and then these events will be removed. Okay, so AE2 is the same. And then this will be removed. Then for IRB interface, IRB number 10, the unique IP will be, instead of 252.253, VRRB, and then this I'll keep priority 100 here, because I need MX1 to be master in IRB 10, and my unique MAC address is 052. Then in VLAN, I need just to copy this line because I need this line here. Okay, I remove it. Okay, so then for unit 12, I change the IP address to 253. VRRB group 11, virtual address 254, which is shared. I just put here the priority to be 110, which means in unit 10, MX2 will be the master. Then I need to change the unique MAC address of this IRB interface. Then unit number 12, it is actually unit number 12, it is an anycast, which means both MXs should share the same IP and share the same MAC, so I'll not do any changes in unit 12. Unit 101, it is kind of, this one is used for ICCP. Each MX have a unique address. This will be 101.2 and unique MAC address. Then for multi-chassis, I just reverse the IPs. This is a multi-chassis ICL links towards my peer. This is my peer address. Then for ICCP protocol, my local address is 2, my peer address is 1, and the management IP address of MX1 is 51. Then for the bridge domain, it will be the same, and everything else is done. So load patch terminal. Commit here. Okay, now let's show IRB interface, IRB pairs. Then we'll have these three IRB interfaces. Let's ping first of all the ICCP. Okay, I'll show no resolve. Okay, for this IRB. Also, we can ping the 10.253 and the 11 should be, we can ping and show no resolve. So here for 10 and 11 we can see the MAC addresses, which is the MAC address we configured, the manual MAC address we configured under the IRB interface 10 and 11. Actually we cannot ping unit 12 because unit 12 is kind of anycast, so the same ID is configured on both MXs. After we make sure the IRB interfaces can reach each other, let's see is ICCP protocol. Okay, so the ICCP protocol get established. Let's wait until the backup get established, and here the redundancy group shows 1. Okay, now we get established, get detected. Okay, and everything looks, redundancy group joined, should be maybe taking some time. Okay, it should be actually showing redundancy group joined 1.1. So let's wait. Okay. Okay, now AE0 is up, AE1 and 2 is not up. Let's see, show protocols Iccp. Let's make sure redundancy 1. So switch options. Okay, let's make sure so switch options. Show protocols Iccp. Redundancy group 1. Okay, let's make sure that we configure redundancy group interface AE1. Okay, we forget very important configuration, which is redundancy group. Okay, so here we miss to configure redundancy group. Set interface AE1 aggregate assignment MC redundancy group 1. Okay, we need to configure this and post AE0 and AE1. Need to configure here terminal. Okay, when I got actually ICCP here, I can see ICCP goes up, but the ICCP, they don't join redundancy group 1. So just I thought to check the configuration, and I find that I missed redundancy group under the aggregate Ethernet interface. So we can show interface AE1 now. Here is redundancy group 1 and redundancy group 1, and I did it on the other side. Now let's see show ICCP. Okay, so now ICCP joined redundancy group number 1. Run show interface AE ters, so I can see the AE interfaces goes up. Run show LACP interfaces. I have 3 LACP interfaces. AE0 is the back-to-back, AE1, AE2 is working, and they are in collecting distributing. Let's see from this side and show LACP interfaces. Same also, AE0 is the back-to-back, MX1, MX2 collecting distributing, AE1 towards Q of X1, AE2 towards Q of X2 collecting distributing. Let's see from Q of X side. Run show LACP interface. Let's get the extensive. AE1 is towards down, is towards the server. AE2, AE0 is towards the MXs. So for Q of, if you see here, the partner is using that here is the system ID that we configured for Q of X for MX1, MX2, which is 0510, and the Q of X2 should be 20. Okay, for AE0, which is up. Here the partner system ID is 0520, which means that interfaces are up. Now let's do a test to make sure that from the servers we can reach our gateways. So here, show configuration routing. Actually, all the servers here, or the servers down here in this diagram, are using routing instances. Okay, so we need to see data center 1, server 1, VLAN 10, let's say. So here we have, from the server side, we don't even need to take a lot of to understand the configuration. It is actually kind of routing instances, and only one interface assigned to this routing instance, IRP10, and there is a default gateway towards, and the default route towards the gateway. So here 10.0.10.1, this one. So let's ping from this routing instance, which is emulating server 1, let's ping the gateway. Or let's ping first 252, the IP address of MX1, 253, and 254. Let's also on Q of X1, make sure the VRRB is working. Okay, in VRRB, IRP10 is a master. Okay, and here is the IP. While in IRP 11, the group 11 is acting as a backup, and the master is assigned to 253, 10.0.53, and the VIP is 254. Now let's go back to the client side. Let's go to VLAN 11. It is just changed to VLAN 11, and I'm reaching the gateway. I'm reaching MX1, reachable. I'm reaching 253, it's reachable. Let's go to VLAN 12. In VLAN 12, there is no unique IP address in MX1, MX2. It is a shared IP address. So let's ping 254. And if we show ARP no resolve, if you can see in 10 subnet, this subnet, so we have in the MAC address assigned to 252 is 051, which is the MAC address of MX1. The MAC address of 10253 is 052. The MAC address of the IRP is the 00005E. 5E is the VRRP VIB MAC address. Should be the same for VLAN 11 actually. So in VLAN 11, let's do the same. Because in VLAN 11 it looks I forget to 253. That's okay. In VLAN 11 is the same exactly. I have 3 MAC addresses, 1 MAC address for each MX unique IP address, and third MAC address for the VIP VRRP VIP address. And for IRP12 there is only 1 IP address, which is the Anycast IP. Now let's see to ping from one VLAN to another VLAN. So now let's ping from VLAN 10 the IP address of the machine, which is the server of VLAN 11, which is 11.1. Okay, let's ping the server in VLAN 12. It's reachable. Let's try from VLAN server in VLAN 11 server. Okay, so now we can reach the server in VLAN 12. Let's start from VLAN 12, ping myself, ping in VLAN 11, and reach in the server IP in VLAN 10. Okay, so let's go back. By this actually we have done for the MCLAG part 1, the MCLAG configuration, and chapter 1 part 1 for MCLAG. Thank you very much.